Welcome and hello. This is an update video in HEC HMS, specifically the new feature in version 4.13. I'm titling it Frequency Storm Updates or Frequency Storm Enhancements. What you see on the screen here is from the user's manual. This is a page that describes the updates to version 4.13. So frequency storm enhancements, they're described briefly right here. There's a screenshot, which we're going to see in a demo that I'm going to conduct in this video right now. All right, so 4.13, I'll leave a link to this page in the description of this video. There's also a webinar that discusses this topic, version 4.13. It's a little blurry, but basically there's 3 bullet points. The first enhancement is to remove an existing feature that was in 4.12 and earlier versions, removing partial and annual conversions. We're going to talk about that. And then allowing flexible input of precipitation frequency depths. So basically you don't have to have all of the depths for every time period. You just need to have at least 2, and then an interpolation will take place. And then finally, this last one, an option to resort the depths symmetrically. So I'll show you what that looks like as well. Okay, so I've got HMS 4.13 up on the screen here. I've created a very simple basin model with just one sub-basin, just enough to demonstrate what we're going to talk about. The first issue is removing partial to annual conversion. So I have a meteorologic model, and it is set to frequency storm. That's the precipitation method. So if I expand that, click on frequency storm, what we don't see in the components editor anymore is that conversion between partial to annual or annual to partial. It used to be the first 2 fields up here in the components editor. So if I bring 4.12 to screen and then scroll up here, I also have frequency storm selected for my meteorologic models precipitation method. And you can see we have annual partial conversion, and then you have an option here. And then the next field down is just a constant value that's used as a multiplier. So anyway, these 2 fields are no longer in the frequency storm data. It starts off with storm duration, intensity position, storm duration, and intensity position. So that's all the same. We're just losing these top 2 fields here. Okay, let me move 4.12 out of the way. Back to 4.13, the next change is allowing flexible input of precipitation frequency depths. So what I've generated here is an Excel file. We have a design storm here. So over 24 hours, there's 7 inches of rainfall. After the most intense hour, it's 2.1 inches of rainfall. After 2 hours, it is a cumulative 3.3 inches of rainfall. So you can see that curve right there. I went ahead and just added some numbers to make a plot right here. So this is the most intense hour I said was the 10th hour of the day. The second most intense hour is right here, the 11th hour. So this would be 2.1. And then the sum of the first 2 is 3.3. So that makes this second most intense hour 1.2. Then that'd be 0.7. And then the next 3 would be a third of an inch. So anyway, this is the distribution I'm going to use in the example for the rest of this video. So let's just put that to the side here and then input our data. So I'm back in version 4.13. Here's the data that I'm using. So it's going to be a storm duration of 1 day. Intensity duration is 1 hour, and then a few other values here. If I scroll down, now I have to input the data, which I have already done. This is the exact same data that we have for the depths of our frequency storm. So 2.1 inches for the first hour, the most intense hour, up to a total of 7 inches for all 24 hours. So just as an example, I'm going to go ahead and run that. So here is my all depths is what I'm calling this simulation, which uses the all depths meteorologic model. That's just what I named it. Let's go ahead and run that. Okay. Click close, and then let's look at the results. So here's all depths. Here's my subbasin. I'll expand that, and then I'll click on the excess precipitation. And then here's the plot right here. I'll click the graph button, and that makes it a little bit larger. And then click the microscope and zoom in, and that makes it even easier to see. All right, so this is pretty much the same data I had in the Excel. So the update to 4.13 is we don't need to specify all the values that we see when clicking on frequency storm and then scrolling down to this table right here. Say, for instance, we only know the depth for 1 hour, 6 hour, and 24 hour, or 1 day right here. So what I'm going to do is just make a copy of this meteorologic model, create copy, and then I'm going to call this partial depths. So we only have some of the depths. Okay. Then I'll copy that. Then I'm going to make an edit to partial depths, click on frequency storm, then scroll down here. And I said we're going to have 1 hour, so I'll remove the data we don't have. Okay, so 2.1, 5.0, and 7.0. So an interpolation is now going to take place. In version 4.12 and earlier versions, an error message would appear to basically say there's missing data or something like that. But now, if there is missing data, it's assumed to be just unknown, and HMS will now perform some sort of interpolation. All right, so I'm going to click on save. And what I also need to do is create a new simulation run that uses this partial depths meteorologic model. So I'm going to come to compute simulation run manager, all depths. I'm going to make a copy of that, call it partial depths, copy, select it, edit button. And then here for my meteorologic model, partial depths, apply, close, close, save. Now let's run it. So partial depths and execute. Okay, that's done. Let's check out the results now. I hit the results tab. Let me scroll up here. Here is all depths. Let's keep that expanded because I want to compare. So here is excess precipitation. Let me go ahead and expand this first. Subbasin 1, excess precipitation. And then if I scroll up, hold down Control, excess precipitation. And let me click on the plot button to make it larger. Okay, magnifying glass. And then let's zoom in. Okay, that looks pretty close, but not exact. I'm going to go up to Edit and then Plot Properties. Let's make that first line a little bit thicker. And then the second plot, let's definitely change the color. How about purple, solid line, and a little bit thicker. Apply and OK. All right. So up until about 8 a.m., we're right on. Then after that, it looks like the partial depths is a little bit higher here, but lower here, higher here. Yeah, I'm not exactly sure what math is being used, but it looks pretty close. We can also go File and then Tabulate if we wanted to actually compare the numbers. So the peak looks like it's the same, 1.42. Looks like we're off about 0.33 here. And then this is probably the largest deviation, but then it looks like it balances out the other way for the previous 2 hours. All right. So anyway, that's a new feature in version 4.13. And then the last new feature is the option to resort depths symmetrically. So let's go back to our HMS. I'm going to click on components, and I'm going to make another copy of this meteorologic model, create copy. I'm going to call this one resort example and then copy. And then I'm going to click on frequency storm. Hold on a sec. Resort example. There we go. Frequency storm. I'm going to come down here to the data. I'm going to delete the existing data. I'm going to use some goofy numbers that I saw in the webinar. So 0.5, 1.5, 3, missing, and then 24 hours is going to be 7 inches. So those are the depths right there. Let's go ahead and run this simulation and then just see what happens. So let's first of all save it and then compute, simulation run manager. Again, I'm going to make a copy just so I don't have to do as much work. So copy, I'll call it resort example, copy, resort example, edit. And then for my meteorologic model, I'm going to use resort example, apply, close. Then we can close this and we're ready to run. So select resort example and then run. Okay, that's done. I'm going to click on results now. Scroll down to the bottom. Here's our resort example results. Subbasin, and I'm just going to click on the excess precipitation. Okay, pop that out as a plot. Yeah, this is it has two peaks called dual peaks. This is not natural. It probably shouldn't happen, and it's somewhat predicted by the data that we put in. So I don't think this would even be a problem if you're a little bit careful with your data input. But if I click on frequency storm, what's happening here is our intensity for 3 hours is more than 1 hour or 2 hours. So this data example itself just kind of looks suspicious to me. But anyway, if we do happen to put this data in, we can avert that dual peak phenomenon by setting this resort symmetrically value to yes. So the only change I'm going to do is change this no to a yes. I'm not going to change any of the numbers down here. But I'm going to save and then rerun this simulation and then take a look at that precipitation Pareto graph one more time. So here are the results. Let me check I'm in the right simulation. Yep, resort example, and then scroll down to excess precipitation. I think we're fixed. Yep. So here we go. Now we're back to just a single peak and a normal looking Pareto graph for our frequency storm. Okay, that is it for our updates regarding the frequency storm. We removed the partial to annual conversion. We no longer have to enter all the data, all the depths for the different durations. And finally, there's this new drop down for the resort symmetric in case your numbers come out a little goofy.